Hello all. In this lecture we are going to see master theorem, all the three conditions of master theorem. So in a problem statement, something like T of n equal to AT n by b plus f of n. The given equation we have to compare with the master theorem. This is master theorem. The T of n equal to AT n by b plus f of n. So condition is a can be greater than or equal to 1 and b must be greater than 1, and this is f of n. So whatever problem statement given to us, we have to compare with our standard formula of master theorem. T of n equal to T of a n by b plus f of n. We'll try to take one example and understand how it's going to happen. Before that, there are three conditions, that condition 1, condition 2 and condition 3. These are the cases, case 1, case 2 and case 3. We'll try to understand what is the answer. In case number 1, that whenever we'll find n to the power log a by b value and we have to subtract some value to get equal to the f of n function. In case number 2, n to the power log a by b and here is equal to epsilon. That means no need to add or delete anything. Then it is equal to f of n. In third case, n to the power log a by b plus epsilon, then answer is equal to f of n. So in case 1, whatever n to the power log a base b, if the answer is greater and I have to subtract some epsilon, then it is equal to f of n. In second condition, when n to the power log a by b is equal to f of n, so that my epsilon value is 0. And the case number 3, n to the power log a by b plus epsilon. That means whatever value of n to the power log a by b, and I want to add some value, add some epsilon value, and then it is equal to the f of n. These are the three different cases. Case 1 minus epsilon, case 2 equal to epsilon, that means epsilon equal to 0, and case 3 plus epsilon, that means I want to add some value, then I will get f of n. If these cases are happen, then what will be T of n? In case number 1, what will be T of n? That n to the power log a by b. Whatever answer with n to the power log a by b, that will be the final answer. In case number 2, T of n equal to n to the power log a by b into log n. In third case, T of n equal to f of n. These are the three cases. In case 1, if that n to the power log a by b is greater and I have to minus epsilon to equate with f of n, then T of n equal to n to the power log a by b. This will be the final answer. In second condition, if n to the power log a by b is equal to the f of n, then final answer is n to the power log a by b into log n. This is case number 2. In case number 3, n to the power log a by b plus epsilon, that means I want to add some value to equate with f of n, then my T of n equal to f of n will be the final answer. Any problem statement, something like, let's take one example and we'll try to understand. That T of n equal to T of n by 2 plus 1. For this equation, can we solve with the master theorem? Yes. Why? The a value can be greater than or equal to 1 and b must be greater than 1. So here b is 2. So I can implement the master theorem. We'll try to solve using master theorem. A equal to 1, b equal to 2, and what is f of n? 1. 1 means I can write with n to the power 0. First step, that find out n to the power log a by b. N to the power log a is 1, b is 2. So log 1 always with 0. That is n to the power log a by b equal to, I have to compare with f of n. I have to compare with f of n. So I will write in detail. N to the power log a by b equal to n to the power 0 answer. So n to the power 0 equal to n to the power 0. That means whatever the epsilon value here, epsilon is a null value. That means equal to epsilon. So that by master theorem, which case will be here? The case 2. Case 2 will be here. By master theorem case 2, what must be the answer? Check here. T to the power n equal to n to the power log a by b into log a. That should be the final answer. So with the problem statement, both are equal. So by master theorem case 2, T of n equal to n to the power log a by b into log n. N to the power log a by b is nothing but n to the power 0 into log n. N to the power 0 is nothing but 1 into log n. So that answer is log n. So my T of n equal to log n for the given problem statement. We'll check for one more example, that T of n equal to 2tn by 2 plus n. Can we implement a master theorem? Check the condition. Yes, a equal to 2, b equal to 2 and f of n equal to n. If we compare with the master theorem, condition is b must be greater than 1, which is going to satisfy. We'll solve this question. Step 1, n to the power log a by b, which I have to find out. N to the power log a by b is nothing but n to the power log 2 by 2, which is equal to n to the power 1. The formula says I have to equate with f of n, log a by b equal to f of n, which I have to check. What is n to the power log a by b? I have found out. That is n to the power 1. And what is f of n in given condition? N to the power 1. That means both are equal. So my epsilon value equal to 0. That means no need to add any epsilon value. So that epsilon equal to 0. I can write here by master theorem, case number 2, I can write T of n equal to n to the power log a by b into log n. This shows that n to the power log a by b is nothing but n into log n. So that final answer, T of n equal to n log n. This will be the answer for my given question. We can use the master theorem at a different approaches, at a different problem statements, only that we have to satisfy the condition. What is the condition? B must be greater than 1 and A can be greater than equal to 1. So with 3 cases, we can easily solve the master theorem. Thank you for the listening.